Assalamu alaikum. So after the introduction of functions, the composite function and inverse function, it's time to start practice questions from past papers. So the first question that has been chosen is from May-June 2012, variant 2 and question number 10. So the functions f and g are defined by f of x equals to x plus 5 for x belonging to all real numbers, and g of x equals 8 over x minus 3 for x belonging to R, but x should not be equal to 3. So we know very well that if it says x is not equal to 3, that is for the reason that when I substitute x as 3, it becomes 8 divided by 3 minus 3, which is a 0, and with that 8 divided by 0 becomes undefined, and we know that functions validity has to be defined, therefore x should not be equal to 3 here. So this is one thing that we have to keep in mind when we have an x in the denominator. So part 1 of this question says obtain expressions in terms of x for f inverse and g inverse. So to get f inverse, we know that if our f of x equals 2x plus 5, then to get the inverse, I have to make x the subject. Therefore, let's say it's y, which is equals to 2x plus 5. Making x the subject, it should be y minus 5, which is equals to 2x. Or in other words, I can say that it x, which is equals to y minus 5 divided by 2. I have made x the subject. To get the inverse function, we know that we have to flip the x to y and y to x. The x and y, they get interchanged because of the reflection in the line y equals x. Therefore, I'm going to say that it's f inverse x, which shall be equal to x minus 5 divided by 2. So this is the f inverse function, and we know that this is for, again, if x belongs to real numbers, then for the inverse also, it will be having the domain so that it belongs to all real numbers. Now for g inverse, the g function is an asymptotic function, 8 divided by x minus 3. X belongs to real numbers, but it should not be equal to 3. All right, just to have a sketch of the function here so that it's not equal to 3, I know that it's the function so that when x is a 3, it becomes an asymptotic function. If x is a 3, this becomes an asymptotic function. So if I substitute x as a 3, I know that this is 3 minus 3, and it says it's 8 divided by 0. Any number divided by 0 is undefined or infinity. So I know that with the value of x as 3, the function is undefined, it's infinity. And if I just move on and if I say that it's g of 4, which is equals to, let's say it's 8 divided by 4 minus 3, so the function value becomes an 8. G of 5, I can say that it is 8 divided by 5 minus 3, which is equals to 8 divided by 2, and the function becomes a 4 here. So what I know is, and obviously when my x is a 0, if I say that it's gx, which is equals to 0, now I'm comparing it with the x-axis, then with respect to this, it will be 8 divided by x minus 3, which is equals to 0, or I can say that in this case, the function is again undefined. So that means it's asymptotic towards the x-axis. It's asymptotic towards the x-axis with respect to the y value, which is a 0. So I can say that if I need to sketch the graph here, then this is how the graph shall be. This is how the graph is going to be for the function for x to be greater than 3. And in the same manner, I can get all the values with respect to x which are less than 2. So I can see that if my x is a 2, then this function becomes 8 divided by 2 minus 3, or I can say it's 8 divided by minus 1, and its function value is a minus 8. And if it is g of 1, then with g of 1, this becomes 8 divided by 1 minus 3, which is equals to 8 over negative 2, and I can see it's a negative 4. And if it's x value, which is a 0, then I can say that it's 8 divided by 0 minus 3, which is 8 over minus 3. And I can say that the function value is negative 8 divided by 3 here. Meaning on this graph, roughly, if I just make the graph here, so roughly what I know is that with respect to this asymptotic line, I can see that when my x is a 0, the y function is a negative 8 by 3, meaning, so what I can see here is when x is less than 3, it's the graph which is asymptotic towards the x-axis, asymptotic towards the negative x-axis, and asymptotic towards the line x is equals to 3. The dotted line is representing x equals to 3, and this is how the curve is going to be. So this is the explanation for all asymptotic functions here. So now let's get back to the question. So the question was asking us to get the expression for f inverse x. So we have the expression for f inverse x, and we know that f inverse x is equal to x minus 5 divided by 2, and x belongs to all real numbers here. And to get the expression for g inverse, stating the value of x for which g inverse is not defined. So to do that, let's start the working. Our g of x equals x minus 3. G of x, it equals 8 divided by x minus 3. And it's for all real values, x belonging to all real values, but not for the value where x is equals to 3. So again, make y the subject so that this becomes 8 divided by x minus 3, or I can just cross multiply and I can say it's 8 minus 3, which equals 8 divided by y, or x is equals to 8 divided by y plus 3. Or in other words, flipping x and y, interchanging both, I can say it's g inverse x, which is equals to 8 divided by x and a plus 3 here. So this is my g inverse function, and here the value of x where it should not be defined is that x should not be equal to 0, because we know if x becomes 0, 8 divided by 0 becomes undefined, and this is what we do not want for the function validity. Therefore, the value of x which should not be there for x is equal to x is equals to 0 here. So this is what the inverse function for g is going to be. Now the second part of the question. Sketch the graph of y equals fx. Now our fx is equal to 2x plus 5. And we got the f inverse also. Our f inverse x was equal to, so we have the f inverse, we have the function equation itself, and now we have to sketch the graph of the function and the f inverse x, making clear the relationship between the two graphs. So to making clear the relationship between the two graphs, we know that there has to be the third line, which is going to be the line of reflection. It's y equals x. So there are three lines to be presented on the graphs. One is the function, the other is the inverse, and the third is the line, which is y equals to x, from where the inverse function is going to get reflected. So to get the relationship between the two function and its inverse, I can just equate 2x plus 5 to x, and I can say it's 2x minus x, which is equals to negative 5, or I can say it's equal to x, which is equals to negative 5, meaning the relationship between the two graph is going to be at negative 5 and negative 5. So just start sketching the graph, the x-axis and the y-axis here. the y-intercept is 5 for the function. So I have the y-intercept. The gradient for the function is a 2, meaning the line has to slope up. So with respect to that sloping up line, I have made the function, which is 2x plus 5. Now to get the inverse of the function, I simply have to switch the coordinate 0, 5 to 5, 0. I know that one of the point of intersection for the three lines is negative 5 and 5. It's negative 5 and negative 5, which lies here. Therefore, 0 and 5 to be sketched. This is going to be 5, comma 0. 0, 5, the y-intercept of the function is getting reflected to 5, comma 0 in the line which is y is equals to x, and this is going to be my inverse function, which is equal to x minus 5 divided by 2. So this is how I will be making the sketch for the function and its inverse. The relationship is negative 5 and negative 5, where the three lines are intersecting each other. Now the third part of the question, given that the equation fg is equals to 5 minus kx, k is a constant, has no solution. Find the set of possible values of k. So that's the inequality that they are asking for. We need to have the composite function f of g, which should be equal to 5 minus kx. So let's start working on that also. So according to the question, it says f of g x should be equal to 5 minus kx, and with respect to that 5 minus kx, and with respect to that we know the condition that there are supposed to be no solutions to them. So to get f of g, I know that in the function f I have to substitute the function g. Function f was equal to 2x plus 5 and function g was equal to 8 over x minus 3, meaning I need to substitute in the function f in place of x the function g, so that this becomes 8 divided by x minus 3, and then there is a plus 5 which is equals to negative plus 5, which is equals to 5 minus kx. Now the 5 on both the sides having the same sign, they become 0. So here I should say it's a 16 divided by x minus 3, which is equals to negative kx. Or I can say that it is 16, which is equals to minus kx into x minus 3. Solving it further, it's 16, which is equals to minus kx squared and a positive 3kx. Just taking minus kx squared plus 3kx on the left, it becomes kx squared minus 3kx and a plus 16, which shall be equal to 0. Now, if there are no solutions, we know that our discriminant b squared minus 4ac should be less than 0. It has to be negative, it has to be less than 0. Substituting b, which is a negative 3k, I'll say it's negative 3k the whole square minus 4 times a, which is a k, and 16, which is my c. It should be lesser or equal to 0. Or I can say it's a 9k square minus 64k, which should be equal to 0 here. Because I'm solving it for the values of k, let's equate it to 0 and get the k values. So here I can say that this k can be taken as common, so that you are left with 9k and a minus 64, which is equal to 0. So one of the value of k is a 0, and for the other I can say it's 9k minus 64, which is equals to 0, and k will be equal to 64 divided by 9. So k equals 64 divided by 9. We need to have this we need to have the values, the set of values of the set of possible values of k for this function to get defined. So what I know here is that it needs to be less than 0, and k is equal, we are getting two values. One is k is equals to 0 and the other is 64 by 9. So just, it's a quadratic curve, and with respect to the x-axis, if I just get the two values, which are 0 and 64 by 9, then for the condition which says it should be less than 0, meaning all the values of k which need to be below the x-axis, this is the region that we shall be getting all the values of x. And from here, I should say that the k values, they lie between 0 lesser or equal to k, which is lesser or equal to 64 by 9 here. So these are the set of values of k for which the composite function equal to 5 minus kx has no solutions. The second question which we need to solve for the understanding purpose has been taken from October-November 2012 variant 3. It's from October-November. This is from October-November 2012 variant 3, and it's question number 7 here. So here it says that the diagram shows part of the curve, one is 11 minus x square, and part of the straight line, which is y equals to 5 minus x, meeting at the points P and Q, A, where P and Q are positive constants. So find the values of P and Q. So we can see that A is the point of intersection for the quadratic curve 11 minus x square and the straight line 5 minus x. So I can solve the two equations simultaneously to get the values of P and Q. I can say it's 11 minus x square, which is equals to 5 minus x, or I can say it's 5 minus x plus x square and minus 11, which is equals to 0. And further, I can say this is x square minus x minus 6, which should be equal to 0. So solving the two simultaneously, I can say it's x square minus 3x plus 2x and a minus 6, which is equal to 0. X common, x minus 3 plus 2 common, x minus 3, which equals a 0, or x plus 2 and x minus 3, which shall be equal to 0, giving me two values of x, which is a negative 2 and a positive 3 here. Now I can see that A lies on the positive side of the x-axis. Therefore, the value of P that we want shall be for the positive value that we have obtained here, which is x is equals to 3. Therefore, the P value becomes a 3. To get the Q value, I can just substitute this x in the equation 5 minus x or 11 minus x squared. So for simplicity, I am taking y equals 5 minus x. Therefore, I can say that y is equals to 5 minus 3, or y is equals to 2. And further, I can say that q shall be equal to 2 here. Therefore, A shall be having the coordinates of 3, 2. So this is going to be the solution for part 1. The second part of the question says the function f is defined for the domain x greater or equal to 0 by I. So for the first part, if the function is 11 minus x squared defined from 0 lesser or equal to x, which is lesser or equal to p, and in this case we already have the value of p, which is a 3, then it means that 11 minus x squared is represented for the domain 0 till 3. And we can see on the diagram that for the domain 0 to 3, we can have the range of the function from 2 till 11, and the range of the function then becomes 2 less than fx less than 11 here. So let's first solve for the first part, which is 11 minus x squared. I know that the function is 11 minus x squared. To get the inverse function, y shall be equal to 11 minus x square, or x square shall be equal to 11 minus y, or x will be equal to plus minus under root 11 minus y. So if I just switch the values which we have to do to get the inverse function, then I can say that f of x is equals to under root 11 minus x. Now to decide between the signs of plus and minus, I know that if I sketch the inverse function, then the actual function was 11 minus x squared given here with a value as 3 and 2, the line of reflection as y equals x. 3 and 2 will just get swapped or flipped in the line y equals x, so that this becomes 2 comma 3, 0 comma 11, which was the y-intercept, that gets switched to 11 comma 0. So I can have the inverse function graph, which can be sketched over here. So this is the inverse function graph f of f inverse x, and this was the function from 0 till 3. So what I have seen here is that all the x values, they are lying on the positive side of the x-axis. Therefore, f inverse x shall be equal to under root 11 minus x, positive under root 11 minus x, to give all the positive values of x here. So the domain of the function shall be from 2 to 11. The domain of the function, it shall be from 2 to 11. This is going to be the domain of f inverse. So I'm just going to write the domain of f inverse as x for 2 to be less than x, which is lesser or equal to 11. This is for the inverse function, and the range shall be, for the f inverse x, it shall be from 0 lesser or equal to f inverse, which is lesser or equal to 3 here. So this is defining the range of the function, the inverse function. And I can see that the domain and the range, they have just gotten swapped here. The domain, which was 0 till 3, has now become the range, and the range, which was from 2 till 11, has now become the range of the function. Now let's do it for the function which is represented by y equals 5 minus x. So the inverse function for y equals 5 minus x, which was actually the second part of the function, I can just say that it's y minus 5, which is equals to negative x, or x shall be equal to 5 minus y, or I can say that this f inverse shall be represented by 5 minus x here. So I have the inverse function for the second part also, which was represented by y equals 5 minus x. Now for this function, the domain function was x to be greater than 3. The domain function was x to be greater than 3. And the range of the function, let's write the range also. The range of the function was fx less than 2 here. So just swap the 2, and I can see that in this case, the domain of the function shall be for x less than 2, and the range shall be for f inverse to be greater than 3. So this is going to be the range of the function. Now if I need to express f inverse in the similar way, then to express f inverse in the similar way, I should simply say that f inverse shall be equal to, in the similar fashion, I would say this is under root 11 minus x, and the f inverse for the second part, which is 5 minus x. So in the similar way, that means I have to represent the domain. So to represent the domain, I should say that under root 11 minus x, the inverse of f inverse, is represented for 2 lesser or equal to x, which is lesser or equal to 11, and this shall be represented for x to be less than 2 here. So this is how I shall be representing the final answer for my f inverse in the same form as they have given us the function itself. Now the third question that has been chosen for the purpose of explanation is from October-November 2016, variant 1, question 8. Why I have chosen this question? I've chosen the question because I can see here that the two functions are again asymptotic functions, and asymptotic function needs a lot of explanation. So let's start with the function. With the question, it says the functions f and g are defined by f of x, which equals 4 by x minus 2 for x to be greater than 0. Definitely for x to be greater than 0, it is an asymptotic function 4 over x minus 2 for x to be greater than 0 here. So for x to be greater than 0, that means it is the function value which is asymptotic towards the y-axis, and when it is towards the y-axis, then it's an asymptotic function over here. What I can see about the graph, the function 4 by x minus 2 is that it needs to be x greater than 0. It needs to be greater for all the x values from 0. So if I substitute x as 0, then obviously this is becoming an undefined function moving towards infinity, therefore asymptotic towards the y-axis. When x is a 1, I can say it's a 4 divided by 1, which is a 4 minus 2. That gives me a positive value, which is a 2. And when my x is a 2, I can see that my function value becomes a 0, giving me the x-intercept at 2, and then so on. Therefore, I can just very easily sketch the graph for the function 4 by x minus 2, asymptotic towards the y-axis. So find and simplify an expression for fgx and state the range of fg. So this is what the question requires. Now this was the additional information about the asymptotic function. Fx equals for the reciprocal function 4 by x minus 2 has been given to you. So starting the question, it says find expression for fg and state the range of fg. So to find f of g, the g function is also a reciprocal function, so that it's 4 divided by 5x plus 2, and this is also defined for x greater or equal to 0. So define for x greater or equal to 0, and the value for which this function is not defined is negative 2 by 5, because I know that if I substitute x as negative 2 by 5, then the function becomes undefined. It's a reciprocal function again. So the question says find f of g. So to find f of g, in the function f, I should be substituting g in place of x. So it's 4 divided by 5x plus 2 and a minus 2 here. So I can say it's 4 divided by 4 over 5x plus 2 minus 2, and solving it further, it's 4 into 5x plus 2 divided by 4 here and a minus 2. So this gets simplified and I'm left with f of g, which shall be equal to 5 of x plus 2 and a minus 2, or I can say it's f of g, which is just equal to 5 of x. So I have f of g which equals 5 of x, and the second part of the question says state the range of fg also. So to get the range of fg, I know that for fg it has to be, we know that for the to form the composite function, the range of g must lie within the domain of f. I know that the range of g, the range of g should be less than the domain of f, domain of the function f here. So the next question is taken from October-November 2016, paper 1, variant 1, and question 8. So why I have chosen this question? Because again I can see that the functions here are reciprocal functions and they need to be explained with respect to the asymptotic graphs, meaning the lines or the axes towards which the graphs becomes undefined. So for the explanation purpose, I know that I have f of x which is equals to 4 by x minus 2, and this is for all values of x which needs to be greater than 0. So for the sake of explanation, if such questions are given to us, then I should know that they have said that x is greater or equal to 0, because I know here that if my x is having a 0 value, then my function becomes undefined, meaning it's asymptotic towards the y-axis, asymptotic towards the y-axis here. And in the same manner, if I want my y to be 0, meaning it's towards the x-axis, then my y to be 0, I will be left with 4 minus 2, 4 by x minus 2, or I can say it's 2 which is equals to 4 by x. And here I can say that in this case, 2 by x, here in this case I can see here that my x should be equal to the value which is 2 here. That means if my y is a 0, my x-intercept becomes a 2, and the graph for this kind of function would be asymptotic towards the y-axis, and this is how my graph should be moving here. So this is going to be the sketch of the graph for the function, so that it is f of x which equals 4 by x minus 2 for all values of x. So this part was done just for the sake of explanation. Now the question says find and simplify an expression for f g x and state, we need the expression for f g x and state the range of f g. So f g x, I have f g and I have g. F is 4 by x minus 2, part 1. Now I'm starting the question. My f of x, this is equals to 4 by x minus 2 for all x values to be greater than 0. And I have the function g which is equals to 4 over 5x plus 2. And this is for all x values to be greater or equal to 0 here. So if I need fg, then for the composite function fg, I know that I just need to substitute my g in place of x, so that this becomes and a minus 2 here, and I can see that my fgx should be equal to 4 divided by 4 over 5x plus 2 and a minus 2, or simplifying it, I can say this is 4 into 5x plus 2 divided by 4. The 4 gets simplified, and here I know that my answer is going to be 5x plus 2 minus 2, which shall be equal to f of g x, which is equals to just 5 of x. It's just equal to 5x. So this is the expression for the composite function f g x here. Now the second part of the question, it says state the range of f g. Now it's a composite function, and if I need to have the range of f g, then for the range of f g, I know the condition which states that range of g should be less than the domain of f. I know the domain of fx, but I don't know the range of g. So for that purpose, what I can do is I have the graph, I have the function fg, and for this function fg, g of x equals 4 over x plus 2, and they have given us the domain which says x should be greater or equal to 2. That means if I substitute this x as 0 in the equation, I will be getting 4 divided by 0 plus 2, which is 2 here. Meaning with x as 0, my y-intercept becomes a 2 here. This is one of the value that I have, and I have the domain which is greater or equal to 0, meaning the y-intercept is inclusive over here. Now, if my y is a 0, meaning if to get the x-intercept, if my y is a 0, I can very clearly see here that the function is becoming undefined, because the function is undefined here. The x value is undefined here. the function value becomes undefined when my y is a 0, because if I make x the subject, what I know is 4 by 0 is equals to 5x plus 2, and this is becoming infinity here, which is equals to 5x plus 2. Any number divided by 0 is undefined. Now that means if I sketch the function g graph, so the range of the function with respect, the domain value is all x greater or equal to 0, and the range of the function I can see is 0 lesser or equal to g of x, which is lesser or equal to 2 here. So this is the range of the function that I have, and I can see that the range of gx is 0 lesser or equal to x lesser or equal to gx lesser or equal to 2, which should be less than the domain of fx, which is x to be greater than 0. So if I just have it on the number line, then I have the value 0, I have the value 2. I know that it is between 0 and 2, and I have the domain which is greater than 0. So what I can see here is that for the function fg, the range needs to be just greater than 0 so that the composite function can be defined here. So this is the working for the range of fg here. Now the second part of the question. Find an expression for G inverse and then the inverse and then the domain of G inverse also. G of x is equal to 4 over 5x plus 2, and it's for the domain x to be greater or equal to 2, and we have also defined the range, which is 0 lesser or equal to gx, which is lesser or equal to 2. So we know for the inverse, the domain and the range, they just need to get flipped. Expression for G inverse, for that I will be substituting gx with y so that it becomes 5x plus 2, or I can say it's 5x plus 2, which is equals to 4 by y, or it's 5x which is equals to 4 by y minus 2, and simplifying it more, it's 5x which equals 4 minus 2y divided by y, or making x the subject, I can say that this is 4 minus 2y over 5y, meaning my G inverse shall be 4 minus 2x divided by 5x. And I have the domain and range for x, therefore for G inverse I can say that the domain just needs to be 0. Domain for G inverse x needs to be 0 lesser or equal to gx, G in lesser or equal to x, which is lesser or equal to 2, and for the range I should say that it's G inverse, which should be greater or equal to 0. So this is going to be the answer for part 2 here. So now this question is from Winter 2017 variant 1, and it's the function f and g, they are defined for x to be greater than 3, and f of x is 1 over x squared minus 9, and g of x is 2x minus y minus 3, and first part says find and simplify an expression for ggx. So that is not a difficult question. We know that the function g of x is given as 2x minus 3. So to get g square or ggx, g square can also be written as ggx. Just in place of x, I will be substituting the function again so that I can see that this is the value, which is a 4x minus 6 and a minus 3, and this answer has to be 4x minus 9. So this is what your g square needs to be. The second part of the question says find an expression for f inverse. We need to have the expression for f inverse, and then we have to state the domain of f inverse also. Now the given question, it was defined for all the x values which are greater than 3. So x values greater than 3, they have given us the domain for x values greater than 3 because I can see here that when my x is a 3, if I substitute x as a 3, the function is becoming asymptotic because it becomes 3 the whole square minus 9, or I can say it's 1 divided by 0, which becomes an undefined function, meaning for all x values to be greater than 3, I should know that this function is asymptotic on the line x is equals to 3, so that this is how the function is going to be. To get the inverse of the function, and I know the range also, the range of the function then becomes, I can just sketch the graph. I can very easily tell the range of the function, and I can say that the range of this function is for f of x to be greater than 0. Now this will help me in making the domain and the range of the inverse functions. Now the only thing that is left is to get the inverse function. So I'll say it's y, which is equals to 1 divided by x squared minus 9. So if it is x squared minus 9, I can say it's x squared minus 9, which is equals to 1 divided by y, or I can say it's x squared, which is equals to 1 divided by y plus 9, or I can say it's x squared, which is equals to 1 plus 9y divided by y here. So solving it further, x will be equal to plus minus under root 1 plus 9y divided by y. So what I can see here is that for x to be greater than 0, if I go for the reflection, then my f inverse is just going to be under root all the positive values of x. So this is going to be f inverse 1 plus 9x divided by x, and the domain and the range, they need to get flipped. Therefore, the domain becomes, I can see that for the sketch that we have made, the range was fx greater than 0. Therefore, the domain becomes x to be greater than 0, and the range of the function shall be, if the domain of the function was for x greater than 3, then the range shall be for x to be greater than, for f inverse x, to be greater than 3 here. So this is how it becomes easy to identify all the values. We have taken the positive value because I can see that if I reflect it in the line y equals x, then the function will be on the positive side of the x-axis. Therefore, f inverse is equals to under root 1 plus 9x divided by x here. Third part of the question says solve the equation f of gx, which is equals to 1 by 7. So we have the function, we have the inverse function. Let's write the function again. The function f of x equals 1 over x squared minus 9, g of x equals 2 of minus 3, 2x minus 3. So to get fg, I know that in the function f, in place of x, I shall be substituting the function g, so that this becomes 2x minus 3 the whole square and a minus 9. So this is my f of g. The question says f of g should be equal to a 1 by 7. Therefore, I will be equating this to a 1 by 7, 2x minus 3 the whole square, minus 9 equals a 1 by 7. Cross multiplying them, I can see that this is 7 equals 2x minus 3 the whole square and a minus 9. Taking negative 9 on the left side becomes 7 plus 9, giving me a 16, which is equals to 2x minus 3 the whole square. Or if I take under root of 16 to eliminate the square, so this becomes a plus minus 4, which is equals to 2x minus 3. And to get the fg function, I can go for f4 plus 3, which is equals to 2x, or I can say it's a 7 divided by 2, which is equals to x. So x can be equal to a 7 by 2 here. Solving with respect to the negative value, minus 4 plus 3, which is equals to 2x, and this will be defined for a minus 1, which is equals to 2x, or x will be equal to a negative 1 by 2. Now the question arises, which of the two values should we consider here? So to consider, so just to see how to consider two of the values, now what I know is that I have been given the function and they are all for x to be greater than 3. So for the domain to be greater than 3, it has been defined that the function f and g, they are greater than 3, meaning all the positive values. Therefore, in this case, I should say that my final answer has to be for x, which is equals to 7 by 2, which is just greater than 3 here. So this is going to be my final answer. So you have to choose between the two regarding what the question has asked us for the domain. The question has given us the domain which is x greater than 3. Therefore, you just need to say that out of the two values, 7 by 2 and negative 1 by 2, your x should be equal to a 7 by 2 here.